Welcome to our channel ICSE Chemistry Hub. Today we will be starting with part 4 of our periodic table series. And today we are going to start with a very important topic called as electron affinity, or it is commonly called as EA. This is a very important periodic test commonly asked in the board exams. So before that, let's quickly have a recap about the topics that we have covered in our lecture 2 and lecture 3. So we had basically started with one of the periodic traits called as atomic size, or it is also called as atomic radius. Now what is atomic size or radius, children? It is the distance from the nucleus to the outermost shell. Then we had also discussed the other atomic trend, that was ionization potential. Now there is a big confusion that what is the difference between ionization potential and electron affinity. So in today's lecture, the difference will be very clear to you. So please go through part 2 and part 3 of my video before you start with lecture 4 of this periodic table series. If you have any doubts, you can quickly have a look through the videos, which is easily available at my channel, that is at the rate of ICSE Chemistry Hub. Also, please do not forget to like, share and subscribe to my channel. So now let's begin with today's discussion. What all are we going to discuss in today's class? First will be electron affinity. As I told you, we'll be discussing the definition of electron affinity. In topic 2, we'll be dealing with what are the factors on which this term electron affinity depends. Topic 3 and topic 4, we'll be discussing how electron affinity differs across a period and how electron affinity will differ down a group. And last but not the least, we are going to discuss the important questions with analysis. So please do not skip this video. Watch it up till the end, because at the end I'm going to discuss what are the important questions that are going to be asked from electron affinity chapter. So without any delay, let's start with the definition of electron affinity. Now, before we start with the definition, I want you to remember the word affinity with the word attraction. Okay, children? So, whenever you hear this word electron affinity, affinity means attraction. Now, if you remember, I had told you for ionization potential, do not remember it as potential. What is the word I had asked you to remember? Remember it as ionization energy. Similarly, for electron affinity, remember it with the word electron attraction. Now, can you tell me whose job it is to attract an electron? Electron is negatively charged. Yes or no? Electron is negatively charged. So, who will attract the negatively charged electron? It is the nucleus that will attract the electron. So, for electron affinity, remember the word electron has to be attracted. The word affinity means attraction. Clear? Affinity means attraction. So let's start with the definition. What is electron affinity? It is the amount of energy released when an atom in the gaseous state accepts an electron. So these are the two keywords that I want you to remember for electron affinity. What is electron affinity, children? Affinity means attraction. So what is happening in electron affinity? It is the amount of energy that is released. Clear? Release means energy is given out when an atom in the gaseous state is accepting an electron. Clear? So once again, what is electron affinity, children? It is the amount of energy that is released. Electron is added into an atom in the gaseous state. Now, why am I referring it to a gaseous state, children? As I had told you for ionization potential also. Whenever we use the word gaseous state, you have to remember the atom is in an isolated state. That means it is alone. It is not combined with anything else. Clear? So this is the difference between ionization potential and electron affinity. Whenever I use the word ionization potential, I had asked you to remember it as ionization energy. In ionization energy, what am I trying to do? I am trying to remove an electron. Yes or no, children? In ionization potential, I am trying to remove an electron, and when an electron is being removed, energy has to be supplied. Yes or no? So what was ionization energy? It is the amount of energy required to remove an electron from an isolated gaseous atom. Yes? Whereas, what is electron affinity, children? Electron affinity, in electron affinity, it is the amount of energy that is given out. Am I clear? Energy will be released here. It will be given out when an electron is added into the gaseous atom. And we know whenever an electron is added, whenever an atom accepts an electron, what sign will it get, children? It will form a negatively charged ion. Am I clear? Which is shown here clearly with the example. For example, let's say an atom X, okay, an isolated gaseous atom X, it accepts an electron. Okay, so when it is accepting an electron, what will happen to the energy, children? Energy will be released here. Yes or no? So it is the amount of energy released when an atom is accepting an electron. So how did I denote the word accept here? With a plus sign. We know whenever any atom accepts an electron, it becomes a negatively charged ion. Yes or no, children? Whenever it is accepting an electron, the atom itself becomes negatively charged. Clear? So now let's start with what are the various factors affecting electron affinity, or what are the various factors that are affecting electron attraction. There are two things on which electron affinity or electron attraction depends. What is the first factor, children? The first factor is atomic size. Clear? And the second factor is, as we discuss it always, it is nuclear charge. So the two factors affecting electron affinity are atomic size, that is the size of the atom, and the second one is nuclear charge, or how powerful the nucleus is. Because here we are dealing with affinity. What is the other word for affinity that I had asked you to remember, children? You have to remember the word attraction. So please do remember, as the atomic size increases, as the size of the atom increases, the more far away it is from the nucleus. Yes or no? So as farther away the nucleus is, as the atomic size is increasing, the more farther it is away from the nucleus. So what will happen to the attraction, children? The attraction will decrease. Okay, so the nucleus, because it is farther away, it will not be able to attract the electron. Am I clear? So as the atomic size increases, the nucleus is becoming more far away from the electron, and so electron affinity or electron attraction will decrease. Please read this. Electron affinity. What is electron affinity? It is the amount of energy released when it is trying to accept an electron. Can you see this? It is trying to accept an electron. A smaller atom, when I say the atom is very, very small, more closer will be the nucleus to the electron. So the nucleus will have a greater attraction on the electron. So more smaller the atom, more quickly the nucleus will be able to attract. More strongly the nucleus will be able to attract. But as the atomic size keeps on increasing, okay, the nucleus is not able to attract it that well. So what happens to the electron affinity, children? The electron affinity will decrease here. The second factor on which electron affinity depends is nuclear charge. What is nuclear charge, children? Nuclear charge is nothing but the atomic number. Yes or no? Okay, who will give me the nuclear charge? The positive charge in the nucleus, that is the number of protons. Okay, now who gives me the number of protons? It's nothing but the atomic number. As the atomic number increases, as the nucleus becomes more and more powerful the nucleus, more will be the attraction. Yes or no? Okay, more powerful the positive charge, more quickly it will be able to attract the electrons. So is this clear to you, children? As the nuclear charge increases, more powerful the nucleus, more will be the tendency of an atom to accept the electron. More the positive charge, more will be the pull on the negatively charged electrons. Clear? So now let's actually start with the trends of electron affinity across a period. When I say across a period, what do I mean by the word across a period, children? I mean from left to right of the periodic table. So without any delay, let's start. We know whenever it is, what is electron affinity first of all, children? It is a tendency of an atom to accept an electron in its isolated gaseous state. Now, as discussed, what are the two factors on which electron affinity depends? The first factor is atomic size or atomic radii, and the second factor is nuclear charge. As the atomic size, okay, can you see here, children? From left to right, okay, we have again taken second period as an example here. When we are moving from left to right in a periodic table, what happens to the atomic size? We know this trend, left to right atomic size is decreasing, which you can very clearly see in this diagram. From left to right, the atomic size is decreasing. So more smaller the atom, yes or no? More smaller the atom, more closer is the nucleus to the electron. And more closer the nucleus, more will be the attraction. Yes or no? This is exactly what is written here. Okay. So as the atomic size decreases, more closer is the nucleus to the electron attraction. Do not remember it as affinity. Remember it as attraction. Am I clear? More closer the nucleus, more will be the attraction. So as the atomic size decreases, when I move from left to right, the attraction of the nucleus to the electron will increase. Clear? What is the second factor, children? The second factor is nuclear charge. Who will give me the nuclear charge? It is given by the atomic number. Yes or no? The atomic number will tell me how powerful the nucleus is. Lithium has an atomic number of 3. Beryllium has an atomic number of 4. Boron has 5. Carbon has 6. Nitrogen has 7. Oxygen has 8. Fluorine has 9. So can you see, children? As I'm moving from left to right, the nucleus is becoming more and more powerful. More powerful the nucleus, more will be the attraction. Yes or no? Which is exactly what is written here. As the nuclear charge increases, more and more powerful the nucleus, more will be the electron attraction. More quickly, the nucleus will be able to attract the electron. So as the nuclear charge increases, the electron attraction also will increase. Clear? So overall, what is happening here, children? What is happening here? Electron affinity, here also it is increasing, and here also, because of the second factor also, it is increasing. So overall, from left to right, electron affinity or EA will always increase from left to right. Moving on, you have to remember certain things while you are remembering the electron affinity trends in a period. Okay, please remember any noble gas. Am I clear? The electron affinity will be 0. I just now told you. What is electron affinity, children? Electron affinity means electron attraction. They are trying to accept an electron. Do noble gases take electrons? No. Do noble gases donate electrons? No. Do they share electrons? No. So please remember, noble gases have got a stable electronic configuration. What do I mean by the word stable? They have completed either their duplet or they have completed their octet. They are highly stable, so they need not attract any electron. They need not accept any electrons. So please remember, very, very commonly asked question. Which element will have an electron affinity as 0? Also remember, the second thing, who is in utmost need to attract an electron, children? Who attracts an electron usually? It is non-metals. Yes or no? Okay. We have already studied in our lower classes. Metals are usually donors. Yes or no? And non-metals are usually acceptors. Now, what is electron affinity? It is a tendency of an atom to accept an electron. So, who will have the utmost electron affinity? It will be group 17 element. Which are the group 17 elements here, children? Group 17 elements are the halogens. Which are the halogens? Fluorine, chlorine, bromine, iodine. Am I clear? Because how many electrons do they have? They have got 7 electrons in their outermost shell. They are very much reactive because they only need more electron. So for electron affinity, it will be highest for halogens and it will be the least for group 1 metals. What is the name for group 1 metals? Alkali metals. Clear? Because when I say group 1, they have got only 1 electron in the outermost shell. They know, no matter how much they try to accept electrons, they are never going to be able to complete their octet by taking electrons, by accepting electrons. Next thing that you have to remember is, greater the value of electron attraction, more the attraction, more is the tendency to accept electrons. Okay, so more the tendency to accept the electron, more non-metallic the element is, more electronegative the element is. As I told you, when they are trying to accept an electron, they get a negative charge. When I say it is negative charge, I mean the more the non-metallic the element is. Clear? Okay, now let's go towards the last trick. That is, how does electron affinity vary down the group? When I say down the group, I mean from top to bottom. Am I clear? Period means left to right and group means top to bottom. Clear? What are the two factors on which electron affinity depends, children? First one is atomic radii, okay, or the atomic size. As you can see in the diagram itself, when I am moving from top to bottom, what is happening to the atomic size? The atomic size increases. Yes or no? We know this trend. Top to bottom, atomic size increases. More larger the atom, more farther away it is from the nucleus. Can you see here? The nucleus is here. It is very, very far away from the negatively charged electron. So the electron attraction here will decrease. Yes or no? Okay. So as the atomic size increases, more far away is the nucleus. Yes or no? Okay. More farther away is the nucleus, less will be the attraction and hence electron affinity will decrease. Next factor, children, it is nuclear charge. And who will give me the nuclear charge? It is the atomic number. Okay. Now I know for hydrogen the atomic number is 1. Lithium it is 3. Yes or no? Okay. So sodium it is 11. Potassium it is 19. So we know as I'm moving from top to bottom, the nucleus is becoming more and more powerful. Okay. So as the nuclear charge increases, what should have happened to electron affinity? It should have increased. Am I clear? More powerful the nucleus, more will it attract the electron. Okay, nucleus is positively charged. It will have a huge positive attraction towards the electron. It will try to attract the electron. So can you see here again, children? One place it is decreasing, whereas one place it is increasing. Whenever you are in a dilemma about which factor should we decide, which should be the deciding factor, I've always told you nuclear charge is not our priority. Am I clear? So atomic radii will always dominate over nuclear charge. Am I clear? Nuclear charge is not our preference here. It's not our priority here. So this effect gets cancelled. So which factor do we take into picture? We only take the atomic radii. So can you see here? Increase in atomic radii dominates over increase in nuclear charge. So we cancel out this effect. So overall, what happens to the electron affinity down the group? Electron affinity down the group decreases. Clear? So let's conclude by just revising what are the trend for electron affinity in the periodic table. Just like ionization potential, remember this, children, left to right, that is across a period, electron affinity increases, and top to bottom, electron affinity decreases. Am I clear? So this is the same trend, just like ionization potential. Clear? So now let's discuss some important questions which were asked in the previous year board papers. Okay. The first question is an element in period 3 whose electron affinity is 0. Just as I told you, what is the meaning of the word affinity, children? Affinity means attraction. And who will have a 0 electron attraction? Who will be not attracting electrons? It will be any one of the noble gases. All the noble gases do not attract electrons. Okay, but here they are specifically asking which is the element in period 3. Okay, so they are basically asking which is the noble gas in period 3. Okay, so period means left to right. Helium belongs to first period, neon belongs to second period, and third period is argon. So you have to search for argon as the answer. So which is the element in period 3 whose electron affinity is 0? It is argon. Clear? Second one. Electron affinity is they are asking you the definition here. So we know it is is it the power of an atom to attract an electron? No. Okay, electron affinity is the tendency of an atom to accept an electron. It is the energy released. Yes, it is the energy released when an electron is added to an isolated atom in the gaseous state. So the correct answer is B. It is the amount of energy released. If it is energy absorbed, it becomes ionization potential. So this C and D cannot be the answer. Am I clear? So the correct answer is B. It is the amount of energy released when an electron is added or when it accepts an electron in an isolated gaseous, and when it accepts an electron, it becomes negatively charged. Next question. Down the group, we have learned that electron affinity will decrease. So down the group, the electron affinity will decrease, and across the period from left to right, electron affinity will increase. Clear? Okay. Next question. So look here, children. The question is in period 3. Okay, period 3, we know it is left to right. They have said an element B, you need not find out which element it is placed to the left of element A. So first I will write element A. So where is element B placed, children? It is placed to the left. So I will place it here. Yes or no? So this is how the board will this time ask questions. It will be more of competency based questions. So they are telling element B is placed to the left of. So element A is on my right. Element B is placed to the left of element A. On the basis of this information, there is some fill in the blanks that is asked here. Element A, they are asking about this element. would probably have dash electron affinity. Will it be less or will it be higher? We know from left to right, electron affinity increases. So can you tell me what will be the electron affinity of element A? It will be definitely, because it's increasing, it will be higher. Element A will have a higher electron attraction as compared to element B. So here the answer will be higher. Okay. Next one, arrange the elements as per the instructions given in the bracket. Okay. So here you have to arrange chlorine, fluorine and bromine in increasing electron affinity. We know this is down a group. Fluorine, chlorine, bromine and iodine. Please remember this as an exception here, children. Okay. We know fluorine, chlorine, bromine, iodine, they are in a group. Yes or no? When I say group, I mean they are down a group, that is from top to bottom. Okay. Now what happens to the electron affinity, children? Actually, top to bottom, the electron affinity will decrease. But here you have to remember an exception. Fluorine, am I clear? Fluorine and chlorine, please remember this. Chlorine has a higher electron affinity as compared to fluorine. So if you are to arrange the elements in an increasing electron affinity, it will be iodine will be the least because it's decreasing. Next, it will be bromine. Yes or no, children? And amongst fluorine and chlorine, please remember this as an exception. What is the exception here? Though chlorine is coming down, okay, and it should have actually decreased. Electron attraction should have decreased. But because of the very, very small size of fluorine, fluorine has a little lesser electron affinity as compared to chlorine. So the correct rank will be iodine, bromine, fluorine and then chlorine. Clear? Next question. Which element has the least and which element has the highest electron affinity? Okay. In the whole periodic table, please remember this. We know from left to right, the electron affinity is increasing. So which element will have the highest electron attraction, children? The highest electron attraction will be for this element called as fluorine, because we know all the noble gases will have an electron affinity of 0. So which element has the highest electron attraction? It will be fluorine, and the least electron will be francium. Am I clear? So the highest one will be fluorine and the least one will be francium. Am I clear till here, children? So please remember this, children. Which element will have the least electron affinity? It will be francium, which comes as an alkali metal, and the highest electron affinity will be for fluorine. Am I clear? Fluorine will have the highest electron affinity because it is a halogen. Clear till here, children? I hope you have understood this topic about electron affinity. Please stay tuned for our next atomic trend, that is electronegativity. So please do like, share and do subscribe to our channel without fail. Please do keep learning and keep revising. Thanks a lot, children.